Hello and welcome. In this video we will use Fluent Polyflow to set up and solve a simulation of a form profile extrusion. Our goal in this case is to determine the die shape required to achieve the desired profile geometry as shown in the picture. Finally, we will post-process and visualize some of the key results like this one. Polyflow is available with the Premium and Enterprise CFD licenses. In this case, we will use the Enterprise license to access all its capabilities. Click on Start to launch the software. Let's start by reading the mesh file. Click Read and then import the file. Once it's loaded, you can see that the geometry is the same as in the picture, including the boundary conditions. You can also rotate the mesh for a better view. The next step is to define the template. Select Extrusion and then the option that matches our goal. This automatically creates the necessary steps in the tree to set up our simulation. We will go through each of them one by one. Go to General and change Steady State to Continuation. Now under Fluid, make sure you have this option selected: the density, the viscosity law and its parameters, and the foaming options shown in the boxes. Under Cell Zones, click on Fluid Zone. Select both regions, the die and the extrudate, and activate the foaming option. The next step involves setting the boundary conditions. You will see regions that were previously defined and created as name selections during the meshing process. Their names correspond to each boundary condition, making the setup easier. For the outlet, select the exit region. For the free surface, also define the fixed part. For the inlet, select volume flow to specify the volumetric flow rate and the bubble radius. Finally, for the wall, select partial slip and enter the friction coefficient. Under Mesh Deformations, first delete the Adaptative option. Next, select the cell zones and name selections that enclose the constant dissection and the extrudate. Now let's check a few settings before running the model. Under the right quantities, make sure all these options are selected. Do the same for calculation activities. Here, enable the double precision buffer, select the number of processors or the GPU, and adjust the continuation controls to match the values shown here. Finally, check these three options under convergence. Next, as a good practice, verify your model setup and click Calculate. During the solution, you can monitor the progress in the Transcript tab and the Plots tab. Once the model is solved, we can create contour plots, vector plots, path lines, and other plots just as in standard Fluent. Here I'm showing how to create a contour plot of a given variable from the list, in this case density. Select all the faces you prefer. Here I missed one, but I can reselect all of them as well as change the legend settings. Continue exploring this tool. This video has come to an end for today. Thanks for watching.